Okay, today we just finished hopefully 7.2 quiz. We're going to do the pre-lab for Kool-Aid and we're going to work on concentrations in lecture. What I'm going to be doing, a lot of you are having trouble accessing the lecture through YouTube. So what I will be doing is, if you go back to your dashboard, hopefully, there is a second one here. I'm changing the picture here, but it's also 1110. This is where your lectures are going to be, and I will embed them so you can watch them without going out to YouTube. So you can watch them here at the school if you need to. So I will still have the stuff going on here, but in here I'm going to embed the videos. Okay, so they're both 1110. You'll still take your quizzes in the fun one, and then I'm working on getting a picture of somebody lecturing here, but this one got her head cut off. But you'll get the idea. Yes. It's not published. It will be published. You guys won't see it yet, but when I start putting videos up there, you'll see that you have two 1110s. Just remember, the fun one is where you take your quizzes, and it will have what we've been doing here with the daily, what happens, but this other one will show where show the lecture if you happen to miss a day. Okay? Yeah, I haven't published it yet for you guys. This is just, come on. Okay, it doesn't want to go back. So we'll just go right into lecture. So concentrations, you have the Kool-Aid lab that I gave you. You just need to make sure that you get the pre-lab done, and you'll be able to hopefully do that by the end of the day where you'll have enough information to do that. Sapling, you should be at 7.2. And we're going forward. You should have finished your test. So I'll put the new date for the next test up. I don't have it right in my head right now, and since we couldn't go back to that other one, I couldn't find it. So I will get the new date up for your next test. Usually about 6 or 7 B days. Okay? All right, so we are now at this point in our notes. So circle which of the following substances would be soluble in water. Remember, water is a polar solvent because we can split it in half, and this side is slightly negative and this side is slightly positive. So if I can get a positive and negative on the geometries of these other chemicals, then I will know if they will dissolve in the polar solvent or if they will not. So the first one is ammonia right here, and I've given you the nice version. Oftentimes it's written just like this, and if you write it like this, it doesn't look like you can split it. Okay? But if you write it like it should be, because this unshared pair of electrons will pull it out of the plane, and you get this, you can actually separate the nitrogen from the hydrogen. And the nitrogen will be the slightly negative side, and the hydrogen the slightly positive side. So because of that, this is polar, and it will dissolve. Okay, let's look at the next one. The next one is boron trichloride. Since boron does not have an unshared pair of electrons on it, it stays in the plane. So I cannot separate boron with one line from the chlorines because it's all in one plane. Because of that, this compound is nonpolar. In other words, as a group, it's nonpolar. I cannot separate it, so it will not dissolve. Looking at the next one, what do you think? That one is carbon tetrachloride. It's often used as solvents for oils and things like that. What do you think? Will it dissolve in water or will it not? Can I split the chlorines away from the carbon? No. This one's nonpolar, and I'm shortening, and you will not be able to dissolve this. What about the next one, sulfur dioxide? Sulfur dioxide. And I gave you a little hint there too because I did the geometry of it. So will it or will it not? I can separate the sulfur from the oxygens, and because of that, this becomes a slight negative and this becomes a slight positive. And if you look at where sulfur and oxygen are, they're right above each other, but oxygen's on the same level as fluorine, and remember, fluorine wants the electrons the worst of all the elements on the periodic table, and oxygen's on its same level, so it will pull the electrons a little bit closer to it. So yes, this is polar, and just barely, but it will dissolve. And then we have let's see, H2S. Hydrogen sulfide is what we usually call it. If you named it as an acid, it would be hydrosulfuric acid. But it is rotten egg gas. And because of the shape, it's like water, it will split. And so it is polar, and it will dissolve. Okay, so going on to the next page here. This is actually in your book, and we're just going to talk about it even though we're not going to read it. Oftentimes they give babies that have, or even young children that have been throwing up or having diarrhea a lot, they'll give them a pediatric electrolyte to drink. Why would they do that? What does that do? What's in it? As teenagers, you go out and you exercise, and they say you drink a lot of water, but then if you're exercising a lot, they say drink some Gatorade or some Powerade. Why would they say that? Yes? You're losing your electrolytes. You're actually diluting your body. If you keep drinking water, the things that carry messages to the rest of your body are your electrolytes or your ions. And if you keep sweating them out, then you lose those ions and you've got to replace them. So that's what's happening here. A lot of the flus that are going around right now are throwing up or diarrhea flus. And so it's really important that you get back the electrolytes, because otherwise your body starts to shut down. So that's what that's about. Okay, so now we're going to go into solutions and concentrations. We actually have a lot of different concentrations that we're going to be working with, and this is going to carry on throughout the rest of the year. The one that we use the most is called molarity. And I made a little ditty to help remember it, and if it works for you, great. If it doesn't, just remember it's moles per liter. So molarity, molitery, molarity, molitery, molarity, molitery, moles per liter. Molarity, molitery, molarity, molitery, molarity, molitery, moles per liter. Okay? The reason why I did that is because there's a lot of concentrations that look like molarity, and we'll get to those in just a minute. So I have to help myself remember, okay, this one is moles per liter, because all of them will have moles per something or grams per something, okay? But this one is moles per liter. Now, you need to make sure it is in liters, and you need to make sure it is in moles. So you have to make those conversions. And it is symbolized by a capital M, like a mountain. Okay? We're going to be going into several others: weight percent, weight volume percent, volume percent, and molality, and we'll get to that one later. So molarity and molality sound a lot alike, but they're totally different. Okay, so let's do some calculations. So calculate the molarity of the following solutions. Again, you're going to be given things like a story problem, so be able to pull them out. So remember that our molarity is equal to moles divided by liters. So I have liters here, 1.25, and I have moles here, so that's going to go on the top, 4.55. And I'm going to divide that, and I'm going to get molarity. If you don't have a calculator out, or you need to borrow one, come get one now. You're going to need it today. 0.364. And I would just label it capital M. Now, if I know what it is, then I would follow that by that, like molarity of NaCl or molarity of sulfuric acid. They didn't tell me what it was of, so I just leave it there. The next one, they do tell me what it is of, KBr. They give me grams, and they give me milliliters. Well, if I look back at my equation, molarity equals moles divided by liters. I don't have either one of those, so I need to convert. So the first thing I need to do is get moles. So I'm going to add up potassium and bromine. So potassium is 39.098 and bromine is 79.904. So I'm going to add that up. So somebody do that real quick for me. Yes. Okay, and that's how many grams there are in a mole of potassium bromide. So what I need to do is I need to take that number, take 11.9 divided by 119.002. This is grams per mole. Grams will go out, and I'll be left with moles. So what do we get for the answer there? Should be 0.1, right? Or 0.99 something. 0.09. 0.0991. Is that what you said?
No, it's
0.0100. Okay, to 3 sig figs. Because that little zero over here, or this little 0.002 is going to make it 0.00. Try it again, 0.00999999, and finally get to an 8 or something. Repeating.
But there's only one zero front, so what is it?
Oh, only 1 0 in front, so I've got, okay. 0.1, yes, 0. Okay, sorry. Thank you. All right, so the next one, all we have to do to get from milliliters to liters is divide it by 1,000. So we're going to divide that by 1,000 and we get 0.2000 liters. Sorry, I ran out of room over there. So then I put in here 0.100 moles divided by 0.2000 liters, and I end up with 1 divided by 2 is 0.5. So 0.05, is that right? So let me double check my math. Or is it just 0? No. It's just 0.5, right? Somebody do my math. Yes. Well, it has that many significant figures. So that's why I put the 000. Okay? 0.5, thank you. My math brain is not working this morning. And then I would put the capital M, but since I did give me KBR this time, I do finish it by putting KBR. So I know what the molarity is of it. Okay, so let's do this next one. This next one, we have a 10 milliliter sample, so right away I'm going to divide it by 1,000 and get 0.0100 liters, right? Again, double check me because it is Friday and you know how Fridays are. 0.01? That's right? Okay. All right, so then over here what I'm going to do is take lithium, and there's 2 of them, lithium 6.941. Sulfur, I have 1 of them, 32.065. Oxygen, we have 4 of them, 15.999. And I'm going to add that up. Somebody got that done? 109, well, 9, come on, right? 109.453. 943. Let's erase that. That's grams per mole, right? Okay, so then all I have to do is take and put the 0.29 grams on top. Grams will cancel, and I'll end up with moles. Sorry, that far corner does not write on my board, so we'll just do it above here. What do we get? Yeah, it's going to be 0.0 something. 265? Yes? No? Do I have a second on it? 0026. You got 3? Okay. Okay, we're close. All right, so then what we're going to do is just get the molarity again. Molarity is equal to moles, 0.00263 moles divided by 0.0100 liters, and we get what? 0.263 molarity of Li2SO4. I'm going to change colors because I don't have very much room underneath. I didn't think very well when I made this slide. So the next thing I want you to do, I want you to try it on your own. This one's a little bit more tricky. You're going to have to add this up, get the mass of this, take this divided by the mass, change the milliliters into liters, and find the molarity of this. So take a second. I want you to do it on your own. Then we'll compare answers. So if you need a calculator, make sure you come up and get one. I've got the yellow ones or the smaller ones you're welcome to use. Whichever one you feel comfortable with. .011 for carbon, 15.999 for oxygen, on hydrogen is 1.008. Okay, how are we doing? We able to do this okay? Okay, you should have got 180 point something. I can't remember exactly what that sugar adds up to be. And you're taking 6.5 divided by 180. What did we get here for moles? 6.6 for the moles? 0.036 moles. Okay, then we just take the moles, divide it by the liters, and we get for a final answer 0.144. Does I have a second on that one? Awesome. Okay, that's a capital M, and then we would put C6H12O6, and that would be our concentration. Okay. That's okay. That's why I look, and if there's more than two that say, yes, that's not right, then I go with that. So it's okay. Everybody makes mistakes with the calculator. Okay, we all right? Okay, let's go forward. All right, so let's do, a lot of times in lab, we're not trying to figure out what the molarity is, but we're trying to make that concentration. So in order to make that concentration, we need to be able to figure out how many grams of something that we need to weigh out to put with so much liquid. If you need to run to get a drink, feel free to do that. Okay. All right, so we're looking up here. We've got molarity is equal to moles divided by liters. And we have been given liters and molarity. So we're going to take and times those together to get moles. Now for moles, we can change it to grams because I can't weigh out moles in lab, but I could change it to grams and I would be able to figure out how many grams I would have to add. So let's go ahead and solve for moles here, which is just molarity times liters. So molarity 0.215 molar times 1.75 liters, and we get an answer of what? 0. What? 376. Is everybody okay with that? Yeah? Okay, so moles, and we would put then NaCl. So it just asked me to go that far on this one. On the next one, I'm actually going to have us go one more step and go to grams. So we're still going to do the same thing. We do have milliliters, so we need to convert that to liters first up. So that was really fast. Divide it by 1,000. Should put 2 zeros there because it's 2 after that are significant. And if I'm going to go to grams, I'm going to have to add that up. So let's add that up real quick. Calcium is 40.078. Is that? Okay, thanks. It's just at a bad angle. And chlorine is 35.453. We're going to add that up. On that one, it's asking to go to moles, but I want to go to grams because I want to know how to make it. So I'm just going to take us one more step there. So good question. I would normally just go to moles because it's set at the top, calculate how many moles. And we'll do that. We're just going to take it one more step. Because moles in lab aren't really helpful, but grams are. Okay, so did anybody get this calculated out? Yes.
110.9.
And that's how many grams are in 1 mole. Okay, so let's do the normal thing over here, which would be to find moles. To find moles, we take the molarity times the liters. And we would get for moles what? 0.895 moles of calcium chloride, right? And that's where it stopped up above, so we could stop there. But what I want to do is I want to find out how many grams I need to measure out in lab. So I took it one more step. That's why we added up the mass. So on the bottom, I would put 1 mole of calcium chloride, and on the top, 110.984 grams of calcium chloride. Moles of calcium chloride will go out, and we can take and times that through, and I can figure out how many grams I need to weigh out, put in a volumetric flask, and then fill with distilled water up to 250. So what have we got? 99.33 grams of calcium chloride. Okay? Are we okay? Yes. These two times together. Because when I rearrange it, this is the equation I'm using. So molarity is equal to moles divided by liters, but if I want to find moles, then I just times molarity times liters. Okay? All right, we ready to move forward? Got some more calculations to do. Okay, so now we want to find out how many liters I need to use if I have, so a lot of times in lab, setting it for lab, I'll have a definite amount of chemical, but I need to make up a solution that's a certain amount. And I need to find out how much I can make up of that certain amount. So that's what we would be doing here. So here's my molarity, and I've been given that many grams. Tell me, how would you approach it? What would you do first? Okay, make it equal L, so we can do that. So molarity is equal to moles divided by liters. So those two basically would switch places. So liters would equal moles divided by molarity. Okay, do I have moles? Okay, what do I need to do to get moles? Yes. Add up the mass of NaCl. So NaCl is equal to 22.990 plus 35.453, which is equal to 58 point something. Somebody got that? 58.44, and that's grams per mole of NaCl. Okay, so I'm going to take that 34.5 grams of NaCl and divide it by 58.44 grams per mole of NaCl. The grams will cancel, and we get moles on top of NaCl, because 1 over moles is a mole. And it should be just about a half, so just about 0.5. What do we end up with? 0.59? 591? Awesome. Okay, so then over here we can put in 0.591 moles divided by 0.345 molar. And remember, molar is moles over liters, so I'm going to end up with liters. About 2 liters. What do we get? 1.79 liters. 71. 1.71. Okay. So that's how many liters I would need to do. Now, if I was doing that in lab, that's really hard to measure out, 1.71 liters. So I could do 1.5, that's an easy one to do, or I could do 1. So I'd have to go back and say, okay, that's as much as I can make, but I'm not going to be able to use all of it. Okay, yes?
Where did you get the 34.5? Oh.
It's all right. Okay, so I've done one. I want you to do the next one. And I'm going to have somebody come up and put it up. Ha, ha, ha. Give you a few minutes to work on it. And I am going to pause the video so we don't have to just sit here and listen. So if you're listening, pause the video so you can work on it. All right, how many agree with the answer that's up on the board? Okay, good. The only thing I would suggest is as you go through, make sure that you also put all the units as you go so that you won't mess up, because that can change. That was actually moles per liter, which is molarity. Okay, so look, on the bottom one here, this is basically how we use in lab also. I did one earlier for you where we solve for grams. So this is what we're going to be doing here. So first of all, again, take and divide by 1,000 to get it out of milliliters into liters. So that would be 0.150 liters. We would add up sodium, 2 times it, 22.990, plus sulfur. Didn't we do this one already? 0.65. This sounds really familiar. And 4 times oxygen, 15.999. And we would get a mass. So anytime it wants grams, I know I'm going to have to add up the mass. So I just do it right up the front. Not sodium, we did lithium. Okay. It just felt really familiar. Okay, has anybody got that added up? It's one, say it real loud. Did I write it correctly? 3.6? 142 point, I always add up to 5. So 142 point, when I'm adding things up, always add it up to 5 and then you won't mess up. So 142.04. Okay. All right, and that's how many grams are in 1 mole, right? Now, I have got molarity equals moles divided by liters. And I have got molarity and I've got a volume. So again, I'm looking for moles, which is molarity times liters, which is 15.0 molarity times 0.150 liters, which will end up giving me how many moles? 2.27 moles. Then I can just take that 2.27 moles, and in 1 mole, there is 142.04 grams, and end up with grams of Na2SO4, which is how many to 3 sig figs? How much? 320 with a decimal. Okay. Do you have a second on that? You got 322. 322? Okay. Go with 322. 320 was close. 322. Okay, so that's how many grams that I would weigh out to put with 150 milliliters. All right, your turn. B. Again, I'm pausing the video. I forgot to turn the video on. So yes, this is good. Make sure that you don't just put M though, it's mole, because M is meters, right? And we're going to actually be going into something else that has a lowercase m, that's molality. And I don't know why the scientists can't use any other letter besides M, because it's really going to be irritating to you, and you'll see why in just a minute. Molarity, molality, meters, all are M's. So molarity is capital M. Meters are regular lowercase m. Molality is lowercase italicized m. It's like, could you pick a different letter of the alphabet, please? Okay, so we have this answer and we're okay with it. This is 160 and it will be grams of AlCl3. Everybody okay? All right, now we're heading into something else. Okay, so keep molarity in your head because we're going to be using it a lot. But we're going to go into another kind of thing. These are percentage problems. Most of the first part is pretty easy. You guys have done percentage forever, right? Whenever you want to know what your percentage on the test is, right? What do? Your score divided by total score times 100, right? So if I want to find the percentage, which is also known as ppH, of a solution, then I take what I'm trying to find the percent of divided by the total amount of the thing times 100. Okay? Now percentage problems can be done lots of different ways. They can be done weight to weight, weight to volume, volume to volume. So we're going to go through all of this kind of thing. So just remember, when you see percent, think in your head, oh, I want to find that percent on the test. What am I trying to find the percent of? That's your top number. So weight percent. Weight percent is weight of the solute over weight of the solution times 100%. So oftentimes they do this when they're making up a saline solution, or they do volume percent, or weight to volume percent. So say I want a certain saline solution to run through a patient, I need to make sure that I make it up correctly, because too saline can actually hurt and fry the veins of a patient, and not enough saline can actually cause them to lose electrolytes and not be able to have the stuff that they need. So it depends on how the doctor orders it, weight to weight, volume to volume, or weight to volume. When you do something like a saline, it's easier to do a weight to volume percentage because I can weigh out the salt, I can measure out the volume of the solution, and I can put the two together. So that sometimes is easier. Weight to weight you can do though, because we weighed out water before, and that's not a hard thing. Volume to volume doesn't work real great when I'm working with something that's a solid, right? Like salt. So that one wouldn't work really good for that. But when I'm working with two liquids, then that is a smart way to go. Okay, has everybody got all the definitions here? Solution. SOL is solution, yeah. I just ran out of room on the bottom. So it's a shortcut. So everybody's got all these down because you'll need to know the units. Now notice on weight per volume percent, the volume is in milliliters. That's sort of unique. You'll need to remember that. Okay, we good to go? All right, so let's do some calculations. Calculate the weight to weight percentage. Remember that water is 1 gram per 1 milliliter, so I can convert it really quickly. So if I'm going to do the weight to weight percentage, going back, weight of the solution on the bottom, that's got to be so instead of like your normal percent where you just do your score divided by the total score, you're actually doing the weight and the weight of the solution. So it's your score and the others. So if we look at this, we could really quickly just change that to grams, right? and we would put 5.3 grams on the top. On the bottom, we would go 100 plus 5.3. That would be our bottom. And then we're going to times it by 100. And then we label it weight to weight, percentage of weight to weight. So what do we get? Usually we're reporting to 2 after the decimal. Doesn't matter how many significant figures I have on percent, we usually report to 2 after the decimal. Anybody got a percent? 5.0 what? 2 after the decimal. Just 3? 2 after the decimal? That's it. So 5.03 makes it 2 after the decimal. So is that the right number? Okay. And we would label it weight percent of sugar. Okay, percent weight of sugar. Okay, let's have you do the next one by yourself. It's not hard. Ryan, why don't you come put that up? Doesn't like it. There we go. Sometimes it's just ornery. Okay, thank you. All right, so his decimal here got erased, and remember we're going to times this by 100 to get there. So is that what everybody else got on that one? Okay, good. Then we get to this next problem, and it's changing it up a little bit for us. It says 15 grams of solid is dissolved in enough water to give 100 milliliters of solution. The density of the resulting solution is 1.20. It should be grams per milliliter if it doesn't say grams per milliliter on yours. So the first thing we need to do is we need to find the mass of the solution as total. So we're going to take that 100 milliliters and we're going to times it by 1.20 grams per milliliter. That way the milliliters will cancel and we'll get the mass of the solution, which will be 120 grams. Everybody okay with that? Then we just do what we would do before. What did I get? 115.0 grams divided by the 120 grams, which is the total mass of the solution. Here I'm not adding on the 15 because it's already included. Does that make sense? Okay, then I'm going to times it by 100, and I'm going to get my percent weight by weight. And we should have added this on the top. Okay. Has anybody got an answer for that one? Because it says in enough water to give 100 milliliters of solution, and the density of the solution is this. So we're already going to be including that in the mass because it's of the whole solution, not just the solvent. Okay, what do we have for an answer here? 4.5, give me one more number. 12.5? 12.5, one more number? That's it? Okay. Percent weight to weight of, what are we in? It doesn't say. So that's what we're going to say, weight to weight, and we don't know what it was.
Can you explain to me why you're timing it by the density?
So when I times the volume by the density, you remember the equation, density equals mass divided by volume. So if I'm wanting to find the mass, then I'm just going to say mass is equal to density times volume. That's what I've got here. That's what I've put through. Okay, hi. You got stuff for me? Yay! Thank you. Yes? Okay, that's where the problem is. You got to make sure you're reading it. So they gave me 15 grams of solution, but then they said it's dissolved in enough water to make 100 milliliters of solution. So I don't really know, was that exactly 100 or not exactly 100? Did I have to put a little bit more in or a little bit less because of this 15? But then they gave me the density of the solution. Because they gave them the density, I can find the mass of the total solution to make this what they did. Okay? All right, let's go forward. Now we're going to do volume to volume. Okay? This is easy, right? So if we look back, I'm going to go back a couple. Whoops, went too far. Volume to volume is volume of solute over volume of solution. So again, we're going to have to add those two on the bottom. So I have 150 milliliters of solution contains 12.0 milliliters of alcohol. Well, they already gave me the volume of the solution. So do I need to add anything to the bottom? No. I'm just going to take 12.0 divided by 150 times by 100, and I'm going to end up with the percent volume of alcohol. Alcohol, I can spell really. That's what happens when you drink some, you can't do anything. I didn't. Okay, what do we get? 8.0%? 8.00? Okay, so 8.00%. Done. Okay, do B.
So what if they don't give you two volumes?
So if they gave me volume of each of them separate, then I would have to add them together for the bottom. So if they said this much volume of water and this much volume of acetone, then I would take the smaller one, that would be my solute, and the bigger one would be my solvent, and I would add them together to make my solution on the bottom.
So what if they gave you
That would be hard because you would have to have a density in order to do that. Okay, what do we got? So 15 divided by 250 times 100. You guys were being scared because you thought I was going to ask somebody to come up and do it. And what do we get? 6%? Volume to volume of acetone. Okay, now we get a little bit tricky. Yes, ma'am?
when we were writing down the things for earlier, volume to volume, like, wait, so
It's volume of your solute divided by volume of solution.
but does it matter what the units are?
The units will cancel. Okay? All right, so let's look at this next one. Consider the blood volume of an adult to be 5 liters. The blood alcohol level is this. That can cause a coma. What is the volume of pure ethanol if consumed in one long drink and assumed to be absorbed completely in the blood would result in the critical blood level? So, thinking back to what we had up here, we're looking for X, which is our amount that was on top. We're going to divide it by the total blood volume of 5 liters, right? But we're going to have to add to that X. So this becomes a little bit of a math problem. We're going to times that by 100, right? And we get for the answer 0.50%. Now we've got to solve for X. So let's do it smart. So divide both sides by 100, right? That would be easy to get rid of the 100. So then we would have X divided by 5.0 liters plus X equals 0.005. Is that right? Did I do that right, math? Okay, so then we're going to times it out on the other side. So we've got X equals 0.005 times 5 times, whoops, try that again. 5 plus, I cannot write plus. It is not having a nice thing. Plus, I cannot do this today. Plus X, there we go. Then we will have X equals 0.005 times 5 will be 0.025 plus 0.005x. Subtract 0.005x from both sides. Then we'll have 0.995, is that right? X equals 0.025. Divide both sides by 0.995, and X equals, so 1, this would be this minus this, right? Did I do that right, mathematicians? No? Yes? Okay, what do we get for X? 0.025 divided by 0.995. 23? 251 liters. Yep, it's only 2, so that's how much you can drink of pure alcohol, pure ethyl alcohol. Yes. From timesing this to here, and over here I took this divided by, or this divided by 100. Okay? The 0.005 times 5 is this, that. Okay? All right, moving forward. Woohoo! Okay, now we're doing the weight divided by volume. Okay, so I have this much grams of solute dissolved in this many milliliters of water to give me a solution with a density of this. Okay, so we've got weight divided by volume. So let's go back and look at the definition real quick, if we can get back. Whoops. Okay, weight divided by, whoops, it won't want more than I wanted to. Weight of the solid divided by milliliters of the solution. Okay, so we're going to go back forward. It's thinking, there we go. So we've got that many milliliters of water, and we've got the mass and the grams, and we need the milliliters of solution. So I know this is what you're going to have to do here. I know this is actually equal to grams, right, for water. So this is a little bit tricky one. I know that I need the weight on top, so I can put that 28.0 grams on the top. But on the bottom, I need the volume of the solution. They give me the volume of the water that I'm going to pour in, but depending on how it dissolves, that might not be the volume of the solution. That's why I had to change the water to grams, because I am going to use density equals mass divided by volume, solving for volume on the bottom, so volume equals mass divided by density. So I'm going to take the mass, which is this, 200 divided by the 1.10. This is grams per milliliter. That will give me the volume in milliliters. So let's take that 200 divided by 1.1. It's not going to be quite the 200, right? It's going to be a little less. Yes? 181.82. Okay, so then I'm going to put that over here, 181.82, and that was milliliters, and I'm going to times it by 100, and that will be volume, weight to volume percent of, doesn't tell me. So what do I get for the weight per volume? Oftentimes, too, they often put this in parentheses, the weight to volume, or the volume to volume, or the mass to volume, or mass to mass, or weight to weight. So what do we get for percent? Should be around 10, 15%. 15.3. 15.40. Okay, percent. All right, you guys do the bottom one. Yes. Uh-huh. No, I don't need the weight of the entire solution. It's weight per volume. We're looking for the volume of the total solution on this one.
For like the mass over density. Yeah. Don't you want the mass of the entire solution to be?
Yes, I would. 228. So how does that affect it? So plus 28. So what does this become? Sorry. Good catch. That needs to be the mass of the solution. So volume is equal to what? Good catch. That is a good catch. 228 divided by 1.1. 207.27. 207.27. I don't know what just went on. I touched the board weird. And this would be then 13 point, it just went away. 13.51, right? Good catch. Speak up louder. Okay, so you guys do B. And I was nice on B. Yeah, I just gave you the two numbers. It's too easy. Where's the fun in this? You're okay with easy problems? Okay, what do we get for the answer? Say it louder. 5.00%? Okay. We okay? Okay, moving forward. So when we make solutions, there is a way that we have to do it. You guys are going to be doing this, so please make sure you're listening. It's not for the next lab, but for the lab after that. So to prepare a solution, we have a special volumetric flask. It's called a volumetric flask. It has one line on it, and one line only. So if it's a 500 milliliter line, this line right here is the line that denotes 500 milliliters. Now remember, when we were working with our meniscus, the meniscus needs to touch that 500 milliliter line. Okay, so I actually fill it up. Let's see, you weigh out your solution, or weigh out your solid. You put it into your volumetric flask. You put it about halfway up with distilled water. And then you swirl and swirl and swirl until the solid dissolves. If you try and fill these up to the top part and then trying to dissolve it, you don't have enough swirling power to actually get the solute and the solvent contact each other and to make it dissolve and mix well. So about halfway, then you add a little bit more, mix it, and then you bring it up to the mark. Okay, that's how you make a solution. So you're actually going to be making solutions, and I'm going to be testing to see if you made them correctly. And if you didn't, you got to go make it again and again until you get it right, and then you get your stamp. Okay, so weigh it out, put it in the volumetric flask, put a little bit in, dissolve it with distilled water. Should put DH2O. Add a little bit more, swirl it, add a little bit more. Then you can be very, very careful, because if you go over the mark, it's wrong. It's too dilute. Okay? All right, so how to make a standard solution. Basically the same, what we were just talking about. A lot of times something takes some heat that we have to measure it with or whatever, but basically the same steps that I was talking to you about doing on the last one. Just had another picture. Okay, you need to make a 250 milliliters of a 3.5 molar NaCl solution. How would you go about doing this? So first step, tell me what to do. Okay, milliliters to liters. Now what? How do I make the solution up? What do I need to know to make the solution up? What do I need to know? I need to know the weight. How do I get the weight? Yeah, how do I make it? Once I found out how much solid, what do I do next? So I'm going to use this equation, right? And I'm going to solve for moles. So I'm going to go moles are equal to molarity times liters. I've got molarity in times liters, so I can do that real quick. And what do I get for moles? Let's put it here. 0.875 moles. Okay, I'm going to have to add up NaCl. We've done that already. It was 58 point something. What was it? So 22.99 plus 35.453. What? Say it loud. I'm deaf. 44. Thank you. Grams per mole. So we're going to take that and we're saying 1 mole, there are 58.44 grams. So I'm going to find out how many, what's the mass. So what's the mass when I times that through? 51.135. You guys, I'm so sorry. It has been one of those days. Okay, so now I've got this. Now tell me what I do with that. Before I can put it in my flask, I've got to, okay, I need to weigh it out. Then I'm going to put it in my flask, right? My volumetric flask. Okay, 3, I'm going to add distilled water halfway up, and I'm going to swirl it. And then I'm going to add more water, like my little pitchers, and I'm going to swirl it. And then the last one, what do I do? To this line, right? Okay, and then I've got the solution made. Okay, I'm a visual person. I could write the words, but I'm a visual person. So I want to make sure, though, on my meniscus, down that line, that meniscus is touching right where it should. Okay? All right, going forward. We also have what's called a dilution equation. Now, if we're in molarity, we can use M1V1 equals M2V2. But if we're in some other concentration, like percent, like molality, like anything else, we want to use C1V1 equals C2V2. If you're in industry, they call it C1V1 equals C2V2 because you have a concentration, you have a new concentration, you have a volume, you have a volume. So they use the dilution equation. If you go on to biotech or medical forensics, they will use the dilution equation, C1V1 equals C2V2, okay, to do calculations. So, yes? So M1V1 equals M2V2 is just for molarity. So it's just saying molarity times volume is equal to molarity times volume. C1V1 equals C2V2 is any concentration, as long as the concentration stay in the same unit, times the volume is equal to that new concentration and the new volume. They're both dilution equations. Okay, so to be more standard with industry, we probably need to do this one. In chemistry, we most often use M1V1 equals M2V2. because we're usually working with molarity. Okay?
So C for
C can represent any concentration, molarity, volume to volume percent, volume to weight to weight percent, parts per million, parts per billion, molality. It can do a lot of different things. Okay? All right, so explain how to prepare the following. These are dilution. We're now diluting things. So when I get sulfuric acid, it comes as 18 molar. I'm not giving you 18 molar unless I'm giving it in a dropper bottle. So I wanted to give you something less dilute or more dilute so that it's not as dangerous. So as we look at this, this is what I do when I do these. I just come to it and say, okay, volume 1, concentration 1, concentration 2. Okay, and then I plug in. C1V1 equals C2V2. What don't I have? I don't have V2, and this is how I do it when I'm doing it myself. So I'm rearranging the equation for V2. V2 equals C1V1 divided by C2, plug in. Okay, easy as that. So C1 was 0.500 molar times volume 1, 200.0 milliliters, divided by concentration 2, 12.00 molar. Molars cancel, and I've got in milliliters how much I need to change it. Yes?
Well, do you feel like you could separate labs same equations like that?
Yep, this is a very constant thing in lab. Okay, so what do we get? 100 divided by 12, so we should be around 8 milliliters. What? 8.33 milliliters, done. And on we roll. Okay, so I would take of the concentrated 8.33 milliliters, I would put about half, because this is an acid. I cannot put water into acid. I have to put acid into water. So I would fill the volumetric flask about 3/4 full with distilled water. Then I would put the 8.33 milliliters in, stir it really well, and then fill it carefully till the mark again. Okay, so acid to water like an otter. Otters go into water, right? Okay, so let's do the next one. Volume 1, concentration 1, concentration 2. So it's the same kind of thing. We've already set up the equation. V2 equals C1V1 divided by C2. And we plug in 2.50 molar times 50.0 milliliters divided by 5.69 molarity. Again, molarities would cancel. And we get what? 21.97 milliliters. And we probably would say 22.0 milliliters because it's hard to measure out that 0.97. Okay? Do the bottom one by yourself. Same kind of thing, just change the concentration to weight per volume. I have to make it fast because we're running out of time here and I'm almost to the end. .0 milliliters, is that what you got? Okay. So this is the end. See, I told you I was right there. We did our quiz 7.2. You've got lecture on concentrations. We need to have completed before you come the pre-lab for the Kool-Aid lab for next time. Okay, so look at it, make sure you get it done. And sapling 7.2. And we'll see you next week. Oh, I did put up the new lab committees for next week. I will not be here Tuesday or Wednesday after school next week. So adjust how you need if you need extra help. Lab committees are, you have to come to one during the term. And I put them either at tutorial before school or after school. You choose one of them. You can also choose to attend 5 extra for 20 points extra in lab each time you come. Okay?